What is sampling rate selection? Let's take an example of a computer and a mobile phone. With the advancement in technology, mobile phones have been working like a mini PC. It functions in almost every way one can imagine, be it for gaming, scientific calculation, for networking, and much more. Comparatively smaller screen, running and designing of various applications and software. Thus, on correlating, we can say that, according to sampling rate selection, the selection of best sampling rate for a digital control system is a result of a compromise among many factors. Let's start with the first compromising factor. The main reason for lowering the sampling rate is cost. A decrease in sampling rate means more time is available for the control calculation. Hence, slower computers can be used for a given control function, or more control capability can be achieved from a given computer. Either way, the cost per function is lowered. With excessive reduction in sampling rate, a number of degrading effects become significant. Now, to find an adequate sampling rate, there are about 6 rules. Continuing with the first rule. For different types of variables, different sampling time is chosen. Fast-acting electromechanical systems require much shorter sampling interval. A rule of thumb says that if we select a sampling period which is much shorter than any of the time constants in the continuous time plant, then sampling interval equals to 1/10 of the smallest time constant or inverse of largest real pole is recommended. Third rule specifies that for complex poles with imaginary part omega d, the frequency of transient oscillation corresponding to pole is omega d. Sampling rate should be based on understanding the influence of open-loop plant model on closed-loop performance of control system. Another rule of thumb based on closed-loop performance is to select sampling interval t equal to or less than 1/10 of the desired settling time. Related terms are